Modern deliberate. Modern generative AI operates on a specific illusion. It encourages users to assume that because a response is fluent, the system possesses operational accuracy. In standard consumer applications, this fluency is the primary metric. The model strings together probable text sequences, creating plausible answers without calculating the underlying mechanics of the subject matter. High-consequence environments, including enterprise strategy, technical due diligence, and legal review, require a different baseline. In these settings, a plausible but structurally incorrect answer creates immediate friction. An autonomous agent misinterpreting a compliance policy or a model failing a logical link in a financial audit leads to verifiable liability and system-wide delays. For an output to be usable, it must be auditable. Decision-makers and systems engineers need to trace the path to a conclusion, verify each component, and identify the exact coordinate of any failure. Relying on generative fluency in logic-sensitive workflows introduces risk. The same linguistic smoothness that makes the AI accessible can often obscure a severe lack of underlying verification. EP Function 03, structural diagnosis, acts as the direct countermeasure to this lack of verification. This capability resides at the operating level. It forces the system to map the problem's architecture as a strict prerequisite to generating any text. By treating the task as an engineering problem, the function ensures the AI identifies specific system nodes and flows before it begins to communicate. This shifts the evaluation metric. Success is no longer measured by how persuasive the prose sounds, but by whether the output contains the specific structural components required for a high-consequence task. This function converts the persistent problem of AI hallucination and loose reasoning into a controlled, investable mechanism for work. The core directive of structural diagnosis is to identify the active architecture of a system. It prioritizes structural reality over surface description. Every system map begins with 2 points: the sources where inputs originate, and sinks where inputs finally resolve. Next, the system maps the exact pathways moving resources, capital, or information between these points. These are the flows. To understand friction, the AI identifies hard barriers blocking the path and constraints that limit the total volume it can handle. It isolates converters, the transformation points where an input is changed from one state into another. It tracks self-regulation by mapping feedback loops, showing how the system corrects its own behavior based on downstream results. Finally, it isolates the critical vulnerabilities. It flags the failure modes where the architecture is most likely to break under pressure. When a dense, ambiguous document enters this framework, the AI must sort every paragraph into these strict operational categories. It cannot rely on linguistic shortcuts. This diagnostic process eliminates ambiguity by forcing the data into a transparent, executable structure. Market demand for this function appears when the cost of unverified AI output becomes too expensive to ignore. Enterprise buyers are moving past the need for simple text summaries. They require explicit diagnostics on why a specific workflow, policy, or contract is succeeding or failing. Deploying undiagnosed AI into professional environments creates specific financial risks. Logic failures in supply chain automation trigger operational delays, while hallucinations in legal review lead to direct liability.
While a casual user might prioritize a persuasive email, an enterprise operator requires structurally reliable, audited work that can be reused in different contexts. Every output must survive the scrutiny of legal teams, compliance officers, and system engineers who are trained to find the breakpoints. As automation deepens in high-value workflows, the financial penalty for a single logical error increases. The demand for structural diagnosis is a requirement for operational continuity in zero-tolerance environments. Execution traction is defined as the verifiable ability to perform this exact architectural mapping repeatedly under intense operational pressure. This diagram demonstrates the execution test. The system converts a vague workflow proposal on the left into an explicit node and edge diagnostic map on the right. This conversion makes the AI's reasoning path entirely inspectable. Every logical step is visible, removing the unpredictability associated with standard generation. In this mode, the AI exposes hidden contradictions within complex agreements that would otherwise be smoothed over by fluent language. When an error is identified, it is structurally classified and logged.
This builds a failure taxonomy that prevents the system from repeating the same logical mistake in future cycles. Defining these operational boundaries makes enterprise processes repeatable. The system defines exactly what it can process and what it must reject. Execution traction proves that EP function 03 transforms opaque generation into a transparent, defensible enterprise asset. Scalability traction is achieved by applying this exact operational logic to different task pressures across multiple industries. The structural map scales horizontally, adapting to verticals such as management consulting, AI governance, technical due diligence, and process redesign. While the surface data changes, the underlying control function remains the same. Whether analyzing a supply chain or a corporate governance policy, the AI is always identifying the same sources, flows, and barriers. This repeatability allows for direct productization. The function can be converted into standardized software modules, automated quality gates, and specific policies for autonomous agents. Proving that the mechanism is repeatable across domains identifies EP function 03 as broad technical infrastructure rather than an isolated tool. The tension between AI fluency and operational accuracy is resolved through this disciplined execution of structural diagnosis. This provides the three components of investment viability: market demand, operational proof, and the ability to scale. Structural diagnosis performs the role of technical infrastructure. It enforces deductive reasoning and auditability within the AI's workflow. As infrastructure, it moves AI from a content creation tool to a system designed for operational safety and high-stakes decision support. Its value is found in the enforcement of strict engineering standards on a technology that is otherwise probabilistic. Structural diagnosis solves the recurring problem of unverified AI output by converting generation into a repeatable architectural capability. This conversion drives traction. It meets a specific market need, demonstrates its reliability through execution, and scales across the enterprise. Enterprise reliance on AI for complex work requires this transition from probabilistic generation to structural discipline. EP function 03 provides the foundational architecture needed for the reliable deployment of enterprise AI.